The aerospace industry globally contributes right now about 2 to 3% of the global CO2 emissions. This portion, if we don't change anything about the way we make products, we build, we operate them, is going to significantly increase over the next couple of decades. So we need to reduce our CO2 contribution in order to reduce our impact on climate change and global warming. And we won't be able to achieve that the way we currently operate. There's already a lot of work going on, especially in the areas of different propulsion concepts, electrification, hybrid or hydrogen fuel cell propulsion concepts. But all of these developments will take time, and they are heavily influenced by the regulatory and safety requirements, as well as budget and schedule constraints. Composites already play a big role in the structures of aircraft, in some cases of more than 50% of the structural weight. And that contributes greatly to fuel efficiency, ranges, operational efficiencies, as well as better payloads and utilization factors. The constraining factors are the high investments into tooling and infrastructure that is required and linked to composite materials. So we need solutions that enable a fast-paced development at a lower cost and at a much higher speed. This can be achieved by enabling fast and cost-effective manufacture of composite solutions. Here at RAMPF, we have developed some innovative resin systems that, combined with our low-cost and prototype tooling approaches and fiber optimization tools such as tailored fiber placement, unlock the full potential of the composites manufacturing. Using our materials and processes, subsystems and prototypes can be manufactured within days to weeks of development stages at an affordable cost. This really enables a groundbreaking and revolutionary concept pursuit of the aviation industry and other industries right now and today.